Good morning. Last time, I believe this is the problem we ended with. Let's see. Let's see if you can remember this. I actually, first of all, quadratic equations means what kind of equation? Second degree, yeah. I saw you flash those two fingers. Yes. I think I told you there were three ways to solve quadratic. Did you remember any of them? I know you do. So how do you solve quadratic equations? There's three things. One, factoring. What did you say? Completing the square. Bless your heart. Yes. And quadratic formula. I just add this. Sometimes, on the completing the square technique, sometimes you already have a perfect square. Well then, wonderful. Thank the Lord. Just go ahead and start taking square roots of both sides. So sometimes you have a completing the square problem where they've already completed it for you. Okay, but basically there are those three techniques. Which technique did I use here in this last problem? Yeah, and to complete the square there was an extra complexity up here. I had to first, we learned that to complete the square, one must have the x squared term with a 1. It's got to have a 1 coefficient, and not a 4 like we had here. And when we had a 4, we had, by the way, there's another way I could have done that. I could have divided both sides by 4, or I had to factor it out. And when you factor it out, it gets a little tricky, doesn't it? What was tricky there? Remember when I did this, I took half of 1, which is 1/2, and I squared it 1/4, and I put a 1/4 here. Now came the tricky part. This one, that's right. This 1/4 is in the process of being multiplied by 4, so this is really a 1 here when you take everything together, and that's why I added a 1 on the right. All right. So let's see how good you are at this completing the square technique, because now we're going to take it to the nth degree. And this is the one that basically, this could well be a final exam question right here. Okay, and here's the deal. Start with the general quadratic. That means any old quadratic. Ax squared plus bx plus c. The a meaning any old generic coefficient out there. And then a different coefficient on the b, on the x, excuse me. And then some constant on the end. So this takes care of any and every quadratic that ever was. Can you solve this for x? Well, I know you're probably thinking, yeah, I can just use the quadratic formula. This is true, but what I want you to do today is solve this by completing the square. So here we go. Remember, the first thing you got to do is I can't have this a out here, right? It's got to be a 1. So what I'm going to do today, well, actually, the first thing I'm going to do is get rid of the c. So I'm going to just simply add a negative c to both sides. Because I know I'm going to need that out of it. Now let's get rid of the a. I could factor it out, but let's divide both sides by a. So then, I divided both sides of the equation by a. Does everybody see that this is where I would arrive? Now, let's complete the square. So take the coefficient of x, which currently is b over a. Take half of that. What's half of b over a? b over 2a, or, yeah, I heard somebody say 1/2 ba. And wouldn't that be the same as b over 2a? Well, if you're going to divide both sides of an equation by something, on the left side, if I'm going to divide by b, don't I have to divide each term by that? Yeah. Now, let's just go back to our completing the square. Half of b over a is b over 2a. And what's b over 2a squared? Well, square the b and square the 2a. b squared over 4a. Okay, we're going to add that to both sides. Okay, now if we did it right, this is a ding, ding, dinger on the left. Sorry, it's a perfect square trinomial on the left. And how does one take the square root of of that? Well, remember, it's just the square root of the first term, the square root of the last term, and the sign from the middle term. Okay, so that, well, I won't take the square root yet, but that's what it is, squared. And on the right side, let's get a common denominator so we can bring these two fractions together. What would be the LCD for A and 4A? 4A, right? So what am I missing in the first one, a 4? So isn't that hang on, I did one thing wrong, didn't I? What did I do? Oh, you know I did one thing wrong. When I squared b, I got b squared. When I squared 2a, what was I supposed to get? Yeah. So here's what I should have on the right. Let me just erase a few things so we can more clearly see this again. Okay, so here's what my problem is before I get a common denominator. What's my common denominator? 4a squared. What am I short here? A 4a. So I multiply top and bottom by 4a. Doesn't that, can everybody see how I combine those now? Now that I have a common denominator, can I not put them together? You're starting to see some familiar things. I don't know, there's something, you should be at least seeing some familiar expressions there. Do you see where I got that from? What's the next step in completing the square? Take both square roots. All right, so this will become x plus b over 2a. And I know what the square root of the bottom is here, so let's do that. But the square root of the top, I don't. So let's just write it like this. Okay, and then I'm almost there. How do I solve for x? Got to subtract that b over 2a from both sides. Okay. Oh, and this should really, I forgot to put a very important thing in this last line. There should have been a plus minus there. And do you notice I have a common denominator there? Look, they both have a 2a. So can I not write this in one expression? Yes. You mean to have a negative there? Oh, absolute value of 2a. I'm not sure. Let me think about that. When they divided through, I'm going to have to think about that. If a was negative originally, then when you divide through by a, okay, that would have created this. That's going to be positive regardless. That's going to be positive. But that one there could be negative. I'm going to have to give some more thought to that. I can tell you this is not real important, but I'll take a look at that. I better write that down though. So y absolute value and what is that? Do you know what page that's on? 112. Thank you. Okay, and that was Liz. Okay. All right. Does everybody see where I got this from? Yes. Right. And what I'm trying to show you is, without completing the square, you wouldn't have a quadratic formula. So when you say your prayers tonight, make sure you thank the Lord for completing the square, because you wouldn't have a formula without that. And this is the kind of thing, and I know this is a challenge, but this is the kind of thing I'm going to ask you to do in an exam. I'll say, all right, given a general quadratic, ax squared plus bx plus c equals 0, solve for x using completing the square. Now, I didn't do anything different on here than I did on that previous problem, but it's always a little bit harder when you're just using general things instead of numbers. It's just, I don't know, students always have a little bit more of a challenge. And yet, we didn't do anything that unusual, so. So anyway, it's kind of weird. I'm giving you an exam question ahead of time, but I usually have that on the exam. And it might be a good thing to have on a test, quiz. All right, on we go. Now, the quadratic formula is the third technique that we use for solving quadratic formulas, quadratic equations. Now, underneath the square root sign in the quadratic formula is this creature called b squared minus 4ac. That has a special name. Excuse me. It is called the discriminant. And the reason is because it allows you to discriminate between, that is, to tell the difference between how many solutions and what type. So if you just look at b squared minus 4ac, you can actually tell already how many and what type. And that's why it's called a discriminant. And here are the basic three, I guess you could say, guidelines. If the discriminant is positive, that is greater than 0, then you're going to have two solutions. I really should say two real solutions. So then there will be two real solutions. And that's all because we can take the square root of a positive number, right? What if the discriminant is 0? Well, what happens when you try to take the square root of 0? You can do it. The answer is 0. And the cool thing happens is plus or minus, what's plus or minus 0? They're the same thing. So are there two solutions now? No, really, there's only one. So if the discriminant ever turns out to be 0, you only have one answer. Cool. And by the way, think about it. When you're solving a quadratic, what you're really doing is you are finding out where this parabola crosses the x-axis, right? I mean, when is a quadratic equal to 0? When it crosses the x-axis. Now, how can a parabola cross the x-axis? Well, typically it'll go like this and cross in two places. Or it might be upside down and cross in two places like that. Or it could do this. It could whiff the x-axis, right? And therefore would have no solution. That one's coming. And couldn't it also do this? Just basically bump the x-axis in one point. And that's the one we just took, where you'd have one solution. One. So more typical is 2 points. It could do this, and in the third case, it could do this. All right, in the third case, what happens when the discriminant is negative? Well, as you know, using real numbers, we stop. We say we can't find the square root of a negative unless we use complex numbers. But right now, we're just using real numbers, and so we have no solution. Well, the cool thing is the discriminant tells you it's kind of like what? An advanced messenger, somebody who comes ahead and says, just so you know, there's going to be 2 answers on this problem. You can actually know ahead of time. Now, that's pretty handy, especially if you're having a little trouble with quadratics. It seems to me this would be a cool thing to make use of. You know, you might say, well, I got 2 answers. Is that right? Look back at your discriminant. Wow, I'm only supposed to have 1. I must have done something. That shouldn't be. That's got to be. It should be 1 solution. And it's a checking device. I do have one more thing at the bottom there. I'll get rid of these date things. Excuse me. It says no real solutions, but actually, if we use complex numbers, there's 2 imaginary solutions here. So that's kind of that's coming ahead. That's coming later. So, but in reals, there's none. All right. The rest of today, I want to just do a pile of examples, try to get you into this. So I'm picking some, I believe these are all from the assignment. So let's do number 12. It says solve by completing the square. Sometimes you'll notice in the book they have directions. On this part, I want you to use this technique. And then in the next section, they'll say, this time I want you to use factoring. Next section, it might say, use the quadratic formula. Okay, and make sure you read the directions, okay? And guess what? It's going to be important that you be able to use all the techniques. So don't just look at this and go, oh yeah, I can do that with the quadratic. Forget that completing the square. Make sure you really want to follow directions. Okay. All right. So, you know, is this a perfect square trinomial already? Well, look at the first term. Is that a perfect square? Yep. How about the last term? Is that? Yep. Let's take the square root of the first term, 2x, square root of the last term, 3. Now multiply 2x times 3, 6x. Double it. This is already a perfect square trinomial. Cool. This is going to be a lot easier. Yes. Well, on a test, if I say solve by completing the square, and you do it some other way, if it's a, you know, if it's, let's say, a 5-point problem, I'd give you 1 point.
Well, you get the same answer?
Yeah. You would definitely get the same answer. So it's so important that you know all these techniques. And why? Why is that? On some problems, you will only be able to use certain techniques. Like on that ax squared plus bx plus c equals 0, there's only one way to do that, completing the square. And so because you're going to be forced at some point to use each of them, I need to know that you know how to do each of them. I'd probably, I'd give you a point for getting the right answer, but you'd like get 80% of the problem wrong, and you don't want to do that. Okay, so everybody agree that we have a ding, ding, dinger sitting here. Oh, cool. So all I have to do is right away translate it into a square. Excuse me. Square root of the first term, square root of the last term, sine from the middle. Okay, now just what? Take both square roots. So we have 2x plus 3 equals plus or minus 0. I don't really need that because is there such a thing as a plus or minus 0? Not really. Actually, 0 is, in a way, it's neither plus nor minus. It's kind of neutral. So I could have left that off in this case. So how do I finish this? Subtract 3 from both sides. And divide both sides by 2. Now, how come I only have one answer? Usually, don't I get 2 answers to quadratics? Yes. So actually, really, if we look at this as a factoring situation, isn't this, couldn't I think of it this way? 2x plus 3 times 2x plus 3 equals 0. And then couldn't you set each factor equal to 0 and solve? And wouldn't you get 2 answers of negative 3/2? So it's like somebody could say, oh, no, you have 2 answers. They're just both the same. All right. Now, let me ask you a question. What if we use the discriminant on this problem? Remember, the discriminant is that thing under the root sign in the quadratic. In my case, what's b? 12, so b squared is, okay, minus 4 times a times c. Okay, what happens? The 9 times 4 is 36, and 36 times 4 is 144, and 144 minus 144 is 0. Oh yeah, if the discriminant turns out to 0, there will only be one answer. Hey, that checks. That makes sense. Okay. On we go. 14. Solve for x. Well, this is not in the right format, right? So when you solve a quadratic, how do you want to begin? What kind of do you want to be your beginning point? You want it set equal to 0. So let's subtract 19x from 33, and let's get it in that format first. You could. Yeah, the thing is, there is a hope that it's possibly factorable. But yeah, I get exactly what you're saying. She's saying, couldn't I just keep the 33 over there? You probably could. But let's just at least check. It could be that this is factorable. And let's at least give it a try. I should look in the book. Yeah, because guess what? I'm supposed to be doing, if you look at the directions in the book, 7 through 20 say solve by factoring. Okay, so I want the 33 over there. So this has got to be a riddle 2 job. And the only way we're going to get 2x squared is if we have a 2x and a 1x. And 33, it's got to be 11 times 3. And then we have 3x and 22x, and 3 from 22 is 19, so that's going to work. And then I need this to be negative and this to be positive, because then it's plus 3x minus 22x. We got it. Now, set each factor equal to 0, so it actually becomes 2 problems now, side by side. And then solve each one. So according to this, I get two solutions. I get a positive 11 and a negative 1.5. Now we should really go through and check them. Let's just let's just do the discriminant check again. Remember, A, B, C only is significant if you've got it in standard form, and that would be this form. So B squared is negative 19 squared minus 4 times A times C. You know what? I don't even have to calculate that. Here's why. What happens when you square a negative 19? You get a positive, obviously a big number. And what happens when you take a negative times a positive times a negative on the second part? That's going to be a positive. And a positive from added to a positive is a positive. And if the discriminant comes out the positive, you should get two answers. And we did. Makes sense. So here's a case where I don't even need to know the number. All right. Questions? 15. This is how it's in the book. Again, it's not in standard form. Let's get everything over on the left. And they told us to factor, so they're not going to tell you that if you can't. You know, that's the nice thing about directions. They're not going to, you know, say factor, and then when you can't, they'll sit there and go, ha, ha, ha. No. They're not that cruel. So I know some of you think people who write math books are that way, but so anyway, this is how are we going to factor this? 4 and 3 is not going to work, right? Because the 4, but 6 and 2 is going to work, yeah. And the negative's got to be the smaller one, like you stated up here. Now you check your inside and outside. Inside, positive 6x. Outside, negative 2x. Yep, that will add up as a positive 4x. Set each factor equal to 0. Yeah, we won't check the quadratic here. I mean the discriminant, but we got two solutions. Check them each. Questions? So by factoring, that's pretty easy if you got your factoring down. All right, we're going to jump to the next part now. And the next part says, solve by extracting square roots. So what they're telling you is, you're going to have perfect squares here. So just go ahead and take advantage of that. You know, I suppose I'm going to violate what they just said. And here's why. This is just so tempting. Do you notice that what we have up here is the difference of two squares? One thing squared minus another thing squared. God, I know how to factor the difference of two squares, don't I? How do you factor a squared minus b squared? A plus b, a minus b. Okay, now let's see if you can follow this. The square root of the, so a, in my case, is plus b. I can't write what I'm thinking. Not good. Times a minus b. So this is like, if you will, a, and this is plus b, and then over here this is a, and right here this is minus b. So do you see how I kind of did the a plus b and the conjugate thing? Now, what is this? This is just 2x plus 9. And what is this? Isn't this just a 1? Because x minus x is gone, and 5 minus 4 is 1. Okay, so really all I got to do is 2x plus 9 equals 0. Okay. So I ignored what they said, and I did this by factoring. Yes.
So, say if you did follow the rule and you did it by extracting the thing.
That would be following the directions, so
Yeah.
I certainly can't fault you for following the directions.
Yeah, I was just wondering, like, if you did follow the directions,
Yes.
how would you do it?
Should I just do it that way? Okay. Okay, here it is again. So had I followed directions, that's not what I meant to write. So I'd start by getting, adding the one perfect square to the other side. Now take both square roots. You've got to take both roots. So really this becomes x plus 5 equals x plus 4 in part 1. But the other part becomes x plus 5 equals minus x minus 4. Now solve each part. Well, you notice something strange happens here. You subtract 5, if you subtract x from both sides, you get 5 equals 4. This is trash over here. Okay? I better not leave that sit on the page, lest somebody think I actually believe it. Yes? Because if you do it on one side, it's the same thing. Let me explain. Yeah, I don't know. It's going to take too long to show you. But one side is enough. What happens is you wind up with redundancy, and two parts of it are exactly the same. So you don't need to do it on both. That's why you notice when I had, in the past, when I had x squared equals 16, you take the square root, you get x equals plus 4 and minus 4. I suppose I should have said plus x equals plus 4 and minus 4, and minus x equals plus 4 and minus 4, but you'll find that it comes down to just x. You only have to do it on one side. Not a very good explanation. What's the last part? The second equation, add x to both sides, subtract 5 from both sides, and this is the answer we got a few minutes ago. So this is how the problem would have looked if we'd have followed directions. Please, general rule of thumb, when you get something that leads nowhere like this, you should have some kind of a symbol indicating that you've rejected that. Like in me, it's just a big X. Or, I don't know, no solution or something, and then another way to write. That probably would be better. Like 5, yeah. Okay. So let's go on now. How about 36? Now we change directions. This part says solve by completing the square. Okay. Solve by completing the square. Well, I've already done, I think this is how it looked, didn't it? Let me make sure. No, it just was like this. Here was the problem as it was stated in the book. Okay? So it's all set up. We don't even have to subtract anything. Take half the b term. Half of 4 is 2. 2 squared is 4. Add that. Of course, you must, to make it legal, add it to both sides. Excuse me. The left side is now a perfect square. And now take both square roots. now you just have two parts. You got to solve this when it's a plus 2 and solve it when it's a negative 2. So when it's a plus 2, what do you get? And when it's a minus 2, what do you get? So we get two solutions, 0 and minus 4. This one, you know, the only thing wrong with me writing it this way is you can't see the original. Let me just quick repeat. This one's so short, let's quick check it. You plug in a 0, does it work? 0 squared plus 4 times 0 equals 0. Yeah. How about negative 4? Positive 16 minus 16 equals 0. They both check. Okay, cool. Questions? 42. Same section. Solve by completing the square. Well, I'm still thinking about your comment where she said, should I leave the 14 over there? Maybe. I still, yeah, I guess they told you you have to use completing the square, so let's leave it over there. So I'm going to spread this out a little bit. So we have room. Let's flank 14 out to the right. So I have room for completing the square. Plus, now, we have a problem though. That 9 cannot be there. So I have two choices. I could either divide the entire equation through by 9, or I could factor the 9 out. Yes? What do you mean the first one? That one? Because, well, only because it was already a ding ding dinger, and so I didn't need to complete the square. I mean, even though the directions were to complete the square, I could already see it fit the rules. The first term was a square, the second term was a square, you know, that thing. Yeah. That's the only reason I was able to avoid it. So anyway, here we are. So let's factor the 9 out. Oh, this is going to be a little bit ugly. All right, here we go. 9. What times 9 equals 12? 12 ninths, which is 4/3. So if we're going to use the factoring technique, right, just check it. If I take 9 times negative 4/3, yeah, I really do get negative 12. Okay, now take half your b term. What's half of 4/3? 2/3. And what's 2/3 squared? 4/9. But what did I really just add to the left side? 4. So therefore, to equalize things, I need to add 4 to the right. Now this is what? In here, this is a perfect square trinomial because I completed the square. Whoop, that's got to be a minus. Now let's get rid of the 9, divide both sides by 9. And now take both square roots. And then add 2/3 to both sides. And that really is two answers, right? One answer is 2/3 plus the square root of 2. The other answer is 2/3 minus the square root of 2. But you really can't simplify those. So that's a good acceptable way to write the two answers. Okay? Yes?
I think I know how you got to where you had it before on the other side, but I can't remember now.
All right. Let's just go over that real quick. You saw how I got this?
Yeah.
all I said was, this 4/9 is really not just 4/9, it's 4/9 times 9.
Oh,
And that's why it's really a 4.
okay.
Yeah. Okay, 43. This is another complete the square. Well, now this is messed up in a number of ways. We got a minus, it's in the wrong order. You know, I can get rid of that minus sign real quickly. How about if I add x squared to both sides? So it's like, let's leave the 0 on the right. Couldn't I go like that? You see what I did, everybody? So I saved myself a little grief. I wanted a 1 to be out in front of the x squared, and I actually got it just by adding it to the other side. Okay, now I got to complete the square, so I really got to get this 8 back out of here. I know some of you thought I wasted my time there, but I could have left 8 over there. All right, now complete the square on this side. Half of the b term is 2, 2 squared is 4. Add 4 to both sides. This should be a perfect square now. Take both square roots. Okay, now where did I get that from? Well, square root of 12 is what? The square root of 4 times 3. And the square root of 4 is 2. But the square root of 3 I can't do. You see what I did there? Lastly, solve for x. Okay, finally we move on to another section. 78 says, hey, this time use the quadratic formula. Okay? But you can't use the quadratic until you get your quadratic in standard form. That is, all the, ax squared plus bx plus c on one side equal to 0. So this isn't in the right form. So let's just do a little bit of algebra to get this in the right form. Now we're set up, aren't we? Now you can use the quadratic formula. X equals minus b. B is negative 40, so minus b is 40, plus or minus square root b squared, 40 squared, I think that's 1600, minus 4 times a times c, all over 2 times a. All right. So now we got to do a little arithmetic here. 4 times 16 times 22. See what that is. Well, it's 64 times 22. $14.08. And that means it's what, 192? And what's with the square root of 192? Is that a nice even number? That's sounding pretty good. 16 times 12. So 40 plus or minus. Oh wait, so 16 times 12 would actually be 64 times 3, wouldn't it? So now we're down to that. Is that right? 64 times? Yeah, that's correct. All right, now we could just simplify that a little bit. Couldn't we divide all of these by 8? So that would be 5 plus or minus the square root of 3 all over 4. So I'd leave it like that. Yes. What I did, in effect, is I factored an 8 out of the top. So 8 times the quantity, 5 plus the square root of 3. And then the 8 from the 32 cancels with that 8. So, by factoring. Here, let me just show this more clearly. So what I did here is I said, and then so that's what I did. I think we're out. I think I've done what I wanted to do. Oh, you can do, let's see, what's 80? That's just another quadratic. I think you probably don't have any trouble with the quadratic, would be my guess. So I guess I didn't write the assignment on here, did I? Well, I got to look it up. Has anybody looked up the assignment already? No, it's not on there either, is it? Okay. Well, let's come up with one. Yeah, I can do the every other odd thing. So let's go with 159 ... So every other odd.